Hello, welcome to my Tech Farm. My name is Igor and I work as a teacher and researcher on Scientific University at Food Engineering Department. And from time to time I'm working with my students on different projects. Most of them are only for educational purposes, but some of them are for industry too. And very common is that we have to use different sensors and we have to see those values on some displays, or we want to control valves or some DC or stepper motors. And earlier, since I'm a mechanical engineer, for this part I always needed the help from my electrical colleagues. But since I'm using the Arduino, I can do it myself, or even my students can do it themselves with only after 2 or 3 lessons. A few words, what is Arduino? It's an open source hardware, a board, where you have different pins, analog and digital. They can be used as an input or output, so you can attach different sensors and read values for those sensors. Or you can use them as an output and you can attach small displays to see values from those sensors. Or you can attach different drivers for stepper or DC motors, for example. Or you can attach a relay or similar. There are different types of Arduino, and most popular is the Uno. And since it is open source hardware, a lot of companies can produce the same board, and it is compatible with the original software because it can be plugged to the PC over USB, and you can transfer the software, and after the development is finished, it can work independently, only it needs the power and it will work without a PC. As I mentioned, the Uno is the most popular version, but if I need more pins, I'm using the Mega. Here you can see the size comparison. It has more pins. If the project is final, then after development, I move to Nano. So again, you can see the size. Sometimes you can find pre-soldered, but very common that you have to solder it yourself, these pins to Nano. And if I need a Wi-Fi, then I'm using ESP8266. Here again, just for size comparison. And it's also compatible with the Arduino development software. The easiest way to start is to buy a kit which includes tutorials, which will use only the hardware which is included in that set. That's very important. And my first kit was this Freenov ultrasonic kit. I bought this version because this was below 20 euros, and in that case I don't have to pay VAT or custom. But I found out very quickly that this is not enough for me. I need more. The next version I got from my boss, the original Arduino kit. It came in only in this carton box. And it came with this tutorial book, which is in German. Unfortunately, my German knowledge is very limited. But of course there are English tutorials for this kit on internet too. But that wasn't enough for me. So next I bought is the most complete starter kit from ELEGOO. Huge box with a lot of sensors and displays. And also I bought the 37 set sensor kit V2. And with this I really can complete a lot of projects we are working on, and usually with some common parts I order a new part from internet so I can complete the set. And then a few weeks ago I was contacted by ELEGOO if I want to do an unboxing of their starter kit. Well, I said, okay, it's fine from my side, but the problem is that it's not complete. I already have these kits, but some parts are already missing because I use them. So they sent me this Super Starter Kit Uno R3 project. So in this video I will do an unboxing, and I will give you some tips for each part where can you use it. Because what is important with these kits or Arduino is that to know the possibilities. It doesn't matter if you don't know immediately how to use it, but for example, it is important to know that there is a hardware which changes the resistance in function of light or maybe in function of temperature, how to connect it and how to use it. You can find hundreds of tutorials on internet. Okay, let's start. A CD. I think USB pen drive would be more modern, but in case that you don't have a CD on your laptop, for example, you can always go to the ELEGOO website and download the content of the CD. Let's see what's on it. And this is content of the CD. We have several languages here. Let's see the English. Here we have codes. It starts from lesson 4. Probably first 3 lessons don't need a code. Then here we have libraries, which you can include in your code, so you don't have to type it yourself. And there is a big PDF. Let's see this one. 163 pages. That's big. We have here part list. Yes, and then here are the lessons and tutorials. Okay, so basically this is what you need. You can go step by step, choose a lesson and test it yourself. Now, if you don't have a CD, you can go to the ELEGOO website, go to the download, search for ELEGOO Uno Super Starter Kit. This zip file will be downloaded. It's approximately 215 megabytes. This is the content of this folder. Here again we have several languages. Copy me first. Okay, I will not copy you now. English. And here it looks like it's not completely equal to the CD version. But yes, here we have different lessons, packaging list. Okay. ELEGOO Arduino, let's see Blinky and the libraries. Very nice tutorial you have if you choose the downloaded version too. And probably this is more up to date, the downloaded version. Okay, let's go back to the unboxing. So very useful is this part list, which we have here on the top of this box. Here you have the ELEGOO Uno itself. Nice, I like this in black color, so you can see the marks very visible. So here, this is the power, this is the analog inputs, and these are digital inputs here. Okay, let's continue. And we have this cable, which goes here. It's a little bit short. Then we have these jumper wires. Male to male. Well, some of them are very short, but there are a few longer ones. Next, I want to take out this breadboard. This is the breadboard, which is very useful here because you don't have to do any soldering. You just need these jumper wires and place them in the holes. It's very good quality. I can feel real good resistance when I'm pressing in. So I'm sure it will not come out easily by accident. Everything you put in this row will be connected. For example, you can connect here the ground and the VCC from Arduino, and every sensor or LED, for example, anything you put on this line will be connected with this. Imagine that you have one very long wire and just solder to that wire. And also here. These cross holes are also connected, but in this direction. So if I plug something here, and if I plug another wire here, it's like it's connected, like soldered together. Then we have this power module. So this power module goes on this breadboard. And here you can see some marks. Plus is a red wire, minus is the ground, it's the blue wire. And now everything I connect here on on plus or minus rail, it's connected with this. And with these jumper wires, you can set, for example, now it's to 5 volt, or the other side, for example, is now set to 3.3 volts. You can power this module from USB, or you can here plug up to 12 volts. Ultrasonic sensor, transmitter and receiver, and it can measure with Arduino, of course, in combination with Arduino, the time where the sound, the ultrasound, bounces from the object. So with this, you can measure the distance from some object. Don't expect too high accuracy, so I think it's approximately 1 centimeter is some accuracy which you can expect from this sensor. The display LCD 1602, 16 characters in 2 rows. Now I couldn't find, and probably it's not included in this kit, is the I2C or I2C module. Let me show you how it looks like. If I have this. Yeah. This is how it looks like. And usually you can buy it when it's already soldered here. Or in this case, we can connect display with I2C module using a breadboard, like this. If you use this ITC, you can connect this LCD module to the Arduino with only 2 pins. Of course, you will need plus and minus the power, but except that, only 2 pins. This means you have more space for sensors, because without this I2C, you need besides the ground, I think 6 wires, so 6 pins will be used on Arduino compared to the 2 if you use this I2C. So it's good for learning, but it is good to know that there is a possibility to use this module, and you will need only 2 pins on Arduino. DHT11 temperature and humidity module. It's just a very simple DC motor. DC motor only need 2 wires, and we have a fan blade, and it can work between 3 and 6 volts. This DC motor, and the fan blade can be attached here on the shaft, and there is it. This is a very small servo motor. And here on the shaft of servo motor you can attach different objects. Servo motor has 3 wires: power, ground and signal. With signal you can control the shaft of the motor back and forward 180 degrees. For example, for a robotic arm or similar. So it is not designed to rotate continuously. For that you will need a DC or a stepper motor. And now let's talk about stepper motors. This motor works on 5 volt DC, and it can be controlled with the signals from Arduino. And with amount of signals you can precise control the position of the shaft, and how fast you are sending those signals. You can control the rotation speed. To connect the motor with Arduino, we need a stepper motor driver. This is ULN2003 stepper motor driver. So you can see here we have 4 wires. They go here, and we can connect the Arduino pins here, because Arduino cannot directly give signals to the stepper motor driver. It requires much higher current. Okay, let's see the content of this bag. We have here a shift register. I think it's, let me find, 74HC595. Now, it's used, for example, if you want to run with Arduino a lot of LEDs, you may run out of the pins, and then using this shift register, you can raise the number of your pins. That is, of course, a nice tutorial, and probably it will be used in a tutorial with the 7-segment display. It works like a 7+1 LED, which can be connected here, but of course, well, Well, I think this can be run only one display from the Arduino, but this one, 4-segment display, definitely not. So for this you will need this shift register because you don't have so many pins on your Arduino. L293D is a driver for DC motors, and with it we can control 2 DC motors independently. Arduino will send signals to control the rotation speed and the direction. Then we have here buzzers, an active one and a passive one. The active buzzer will generate a tone using an internal oscillator, so all that you need is a DC voltage to these 2 pins and it will create a sound. Now it's a little bit more expensive compared to this passive one because that oscillator is built in, which will create the sound. But the passive buzzer requires a signal, a PWM signal, which is oscillating basically, and it will create this sound. Imagine that you put here a DC voltage, but that voltage has to pulse very quickly, and depending on the frequency of the pulse, it will create different sound. Next, what I have here is a potentiometer. I will place it in, and I can rotate it, and with this I can adjust the resistance. This is 10K, so 10 kilo ohm potentiometer. Well, this small thing, it will be hard to see, is NPN transistor. It can act like a switch controlled by Arduino. Relay is electronically operated switch. It can use 5-volt signals from Arduino, and an electromagnet will turn on off the switch. For example, with this we can enable or disable 20-volt LED or 24-volt DC motor, which requires higher current. And here we have remote control. Probably it has battery inside. If I pull out this foil, then the battery will be in connection. So it protects the battery. Very nice feeling. And you can program it that Arduino can actually then read which button is pressed, like a push button. But of course, it cannot read directly. So to read the remote control, you will need ER receiver. Next is this connection to the here it is, power connection, and this is 9-volt battery, which is included and very nice protected. Until you in development phase, the Arduino will be powered from USB. But when you finish the project and you don't need a computer anymore, in that case you can remove it and give it the power from 9-volt battery. And with this you can give mobility to your project. And of course here we have some set of resistors. Resistors can be recognized by its color scheme, but of course it's very useful that it's written here. So this is 220 ohms. Probably I will use this one with some LED just to demonstrate you one lesson from the tutorial. And this is just a cap for, here it is, for a joystick. Let me show you. Here, it's not just like a push button joystick, but I can feel resistance here. So properly it acts like two potentiometer, and it can recognize in which angle is this small joystick. Of course, this cap goes on the top. Very nice. And I think it can even be pressed, so joystick can move in 2 directions, and also it can it acts like a push button. Female to male wires. What else we have here? Well, some LEDs in different color, And I can see one LED, I'm not sure will it be visible on camera, with not two but four legs. That's the RGB LED. Simple LED can give lights in one color, but color of RGB can be controlled from Arduino. This is properly the tilt ball switch. And I can feel the ball inside. So probably it can detect when it's tilted. So here we have two pieces of diode rectifier. There is a mark on it because it will allow the flowing of the current only in one direction. So for example, you can use it to create some to prevent spikes from DC motor when it's turned off. It may create a negative current and you can prevent it by these diodes, for example. Okay, what else we have here? A standard push button. When it's pressed, I think in this direction circuit is connected, but it's not stay in that position, so you have to push it, and if you release it, and it will go in start position. Okay, 5 pieces. And then we have here, I think it's photoresistor, and 2 pieces of it. It's a resistor which change the resistance depend how many light it gets on the top. So you can detect is it daylight or night. And a thermistor, similar like that photoresistor, this is thermistor which change the resistance in function of the temperature. It goes here. And you can solder to these holes. And that's it, I think. Yes, the box is empty. Now that would be the unboxing of this ELEGOO starter pack, but somehow I feel that I have to do at least one very simple project to complete this video, and that will be so-called Blinky. That's very basic project where I will make with Arduino to make one LED blink every 1 second, for example. And for this I will need a breadboard, the Arduino Uno itself, one LED, one resistor, I think I will need this one 220 ohms, of course a USB cable and some jumper wires. And when the project is finished, I want to plug off from a computer. I want to power it from this 9-volt battery so you can see that the project can run independent from the computer. Next step is to start the Arduino software, and then in File, Examples, Basics, open the Blink code. And it's already prepared. It will turn on and off the LED built in on the Arduino every 1 second. Of course I have to plug in the Arduino to computer. Then I have to go to the tools, set the Arduino Uno type of the board, then go back to tools and find the correct port where the Uno is attached. In my case it is COM4. And I will not modify anything, I will just upload the code to Arduino. And it's blinking 1 second, every 1 second. Just to test is the code correct. Let's say we want to the LED on for 3 seconds. And only for half seconds I want it turned off. Uploading, I have to wait the code is uploaded to Arduino. And here it is, it's working. So 2 seconds is on and then half seconds is off. Now I want to do this everything, but now with external LED. Now let's find the power on Arduino Uno. There is a ground and there is 5 volts. And I put them into these 2 rails. Now I have 5 volt power here in between these 2 rails, but I cannot connect directly the LED into this because that current will be too much for these small LEDs, and I have to reduce that current using this resistor. And it is important to know that LED has 2 wires. One is a little bit longer one, the other is shorter. The longer is plus and the shorter is minus. So first I will place a resistor into plus into this rail here. So I'm taking plus into this rail, and now I can put a plus of the LED into this rail and to, for example, this next one. And I can go back now to the ground. Let's make it black. So now the LED is constantly on, but I don't want it to be on constantly. I will take out the 5 volts and I will place it in one of the digital pins. For example, 13. Because the 13 LED is connected directly to this pin. And that's what I'm getting here. You can see they are blinking synchronously. And what I want to demonstrate is that I will completely unplug it from computer and power it from the 9 volt battery. And the program is running by itself, so it doesn't need a computer because it's compiled and it's on this chip on Arduino board. And now I have a mobile project. Well, that will be it. I hope I could give you some directions how to start if you are new in this topic. It's really good fun and you can learn very useful things. And as I mentioned, it is not to know the possibilities. It's not important that you know immediately how to use every part, but to know what can that sensor, for example, do, what are the possibilities of that hardware. And I have a permission to upload most of my projects which I work here in Video Students, and they're very interesting between them. Also there will be several which are related with 3D printing, so I hope you will follow me to that video too. Until that, thank you for watching and have fun. Bye.